Tak dobrý den, jmenuji se Michal Valoušek, jsem vývojář webových aplikací a dneska jsem si připravil takovou krátkou prezentaci o mapách hazardu, na kterých jsem dělal. Než se dostanu k nějakým věcem techničtějším, tak bych se rád vrátil na začátek tohoto roku, kdy na Vsetíně byl barkem, kde měl Honza Boček přednášku o datové žurnalistice a v rámci ní vzpomněl aktivity občanského sdružení Brnění, které se zabývá mapováním hazardu na území Brna. Mně se to líbilo a protože ve městě, ve kterém bydlím, tam ta situace taky není ideální, tak jsem se rozhodl, že udělám něco podobného, ale v kontextu mého města. A udělal jsem asi během 2 večerů takovou jednoduchou statickou stránku, ve které jsou využity takové ty klasické Google API, kde špendlíky reprezentují herny, ty zelené polygony, to jsou budovy v jejíž okolí a nesmí být umístěné herny. A celé jsem to nějak narouboval do sebe a je vlastně možné rychle zjistit, které z heren porušují zákon a které jsou v pohodě. Tohle to byla jenom taková zkouška pro mě, nebo chtěl jsem tím jakoby připravit podklady pro zastupitelstvo, které se rozhodovalo, co s hazardem udělá. Z toho technologického pohledu to fakt není nějak zvlášť zajímavé, tam se používají ty bazální objekty. Mnohem zajímavější bylo, jak ty data připravit. Tam jsem využil webového frameworku Django, který v sobě přímo má nějakou podporu geografických objektů. Konkrétně pro výpočet toho 100metrového okolí, jak jste si možná tady všimli, tak tady jsou, to tmavě zelené, to jsou prostě obrysy budov a okolo nich je vždycky nějaká zóna, a to je právě 100 metrů. Tak to se celkem jako jednoduše udělá přímo v Djangu, na to je metoda buffer, kterou když zavoláte na libovolném polygonu, tak dostanete zpátky jiný polygon, který reprezentuje to okolí. A stejně tak jednoduše je možné třeba počítat konflikty, kdy máte bod, nějaký polygon a zase zavoláním nějaké jiné metody contains dostanete true nebo false podle toho, jestli jste uvnitř polygonu nebo mimo. Tady se ještě trošičku zdržím, jak asi všichni tušíte, tak těch způsobů, jak vyjádřit pozici na zeměkouli je víc. Ten klasický je zeměpisná šířka a délka, kdy vlastně 2 souřadnice vám řeknou, kde na zeměkouli se nacházíte, a pak existuje celá řada projekcí, jak zeměkouli natáhnout na nějakou rovnou plochu. Tohleto v Djangu se řeší tak, že můžete u polygonu zadat nepovinný parametr SRID a potom nějaké ID, nějaké číslo, a to číslo vyjadřuje, v jakém souřadném systému se budete pohybovat. Kdybyste to nechali jen tak, bez toho, aniž byste to číslo ovlivňovali, tak zavolání metody buffer, jakože vypočítej mi okolí, okolo bodu, tady v naději, že to bude 100 metrů, tak by vám dalo něco podobného, což určitě 100 metrů není. Musíte říct, musíte mu říct, v jaké soustavě se pohybujete. Já nemám žádné geografické vzdělání, tak jsem si musel prošlapat ty špatné cestičky, až potom jsem našel, že konečně můj souřadný systém, ve kterém mi bude všechno vycházet, je křovák. To je tady tohleto ID. Když potom zavoláte ten buffer s parametrem 100, tak opravdu dostanete 100metrové okolí okolo toho čtvrtu, to je budova, to žluté uprostřed a tohleto je to okolí. Takže tady v tom krátkém, v té první verzi vlastně ty 2 největší úkoly, nebo ty problémy jsem vyřešil jednoduše za použitím Djanga, které má prostě v sobě všechny ty funkce, které jsem potřeboval, a chybělo už mi jenom získat pozice heren a budov, a to byl víceméně takový manuální proces, kdy jsem měl vlastně ty údaje na papíře, nějak manuálně jsem je přenesl do toho skriptu a potom vykreslil. No a v ten moment mě došlo, že kdyby se povedlo nějakým způsobem interaktivnějším zadávat ty data nějak lépe, tak by z téhleté jednoduché věci se mohla stát jakoby plnohodnotná aplikace. No a tak vlastně vznikly mapy hazardu. Tady mám druhé demo. To je v podstatě to samé, akorát jinak nabarvené, co v tom prvním případě. Akorát s tím rozdílem, že je jako na první pohled vidět, které ty herny jsou povolené a které ne. Opět tam zase funguje nějaký hoover, zase jde si rozklikávat, jako, kde jsou problémy a kde ne. Co je ale zajímavější, spíš byl ten proces toho zadávání dat, protože jsme to chtěli právě otevřít lidem, protože jsme měli signály, že ta situace není jenom v Brně špatná, ve Valmezu, ale všude v České republice, tak nás napadlo, že využijeme už to, co Google mapy mají. Dřív se to jmenovalo Moje místa, to se to jmenuje Moje mapy se to dřív jmenovalo, to se to jmenuje Moje místa. Takové jednoduché tlačítko přímo na maps.google.com. A tady, když ťuknete, tak si můžete nakreslit mapu, jakou chcete. Z té základní funkčnosti tam můžete zadávat špendlíky, lomené čáry, polygony, já myslím, že to snad bude všecko. Tak my jsme využili tyhlete funkcionality k tomu, že jsme po lidech chceme, aby nakreslili dvě mapy. Jednu se špendlíkama, které reprezentují konkrétní místa heren, a druhá mapa, která obsahuje seznam budov, které jsou chráněny zákonem a v jejíž okolí ty herny být nemůžou. Pak se tyhle dvě mapy, respektive URL na ně, fouknou do formuláře, klikne se na nahrát a aplikace si potom stáhne ze serveru KML, ten XML popis mapy, vyzobne si tam, co potřebuje, název školy třeba, tady jsou souřadnice té budovy a vypočítá z nich už všechno potřebné, to okolí, konflikty a pak to nějak prezentuje. No ale tohle to fungovalo celkem v pohodě do konce léta, kdy lidi prostě kreslili ty mapy nějak spontánně, že si sedli večer k počítači a během hodinky tam naklikali nějaký 40 heren třeba a budov a už to něco ukazovalo. Ale na konci léta se nám povedlo získat oficiální seznam z Ministerstva financí, který to bylo asi 42 000 záznamů o hernách v České republice a to bylo jasné, že už jako s tím moc jako kreslit nebudeme. Tak jsme to vymysleli takhle, že jsme celou tu tabulku, kterou jsme dostali z ministerstva, natáhli do Google Docs. Potom jsme doplnili GPS souřadnice, protože oni tam, to, co nám oni dali, byla jeden sloupeček obec, druhý sloupeček ulice. Tak s pomocí Google Geocode API jsme vzali vlastně název ulice, město a Česká republika, poslali to na Google Geocode API a vrátili se nám přesné souřadnice té herny, kde je umístěná. A potom s pomocí knihovny Gdata Python klient jsme se spojili s tou vzdálenou tabulkou v Google Docs a řádek po řádku jsme si vyčítali jakoby ty adresy a doplňovali jsme do nějakého posledního sloupečku zjištěnou pozici. No a pak ten výsledný obrovskou tabulku jsme rozřezali na asi 1000 KML souborů, vždycky po obcích. A ty jdou potom následně naimportovat, zase se vracíme zpátky k tomu jednoduchému nástroji, pomocí kterou se dají kreslit mapy, dají se celkem jednoduše naimportovat a doplnit vlastně, pokud třeba máte ve městě, já nevím, 5 heren, které znáte, protože jsou na cestě do práce, tak my vám můžeme dát KML, to si tam naimportujete a dostanete tam hnedka další herny, které máme právě z toho zdroje z Ministerstva financí. No a to už se dostávám ke konci. To je právě zase ten poslední bod, kde získat ta data samotná. Jestli jste dávali pozor, tak já jsem říkal, že na začátku potřebujeme k tomu mít data o hernách a o budovách. Teď máme obrovský dataset heren, ale neznáme veřejné budovy v daném městě. Tak jestli můžu teda jako tady využít trošičku toho, že tady stojím a něco říkám, tak kdyby se vám chtělo, tak navštivte tu první zmíněnou adresu, kde najdete seznam všech těch KML souborů exportovaných z té obrovské tabulky a stačí, když si na chvilku sednete, nakreslíte pár budov, jako jsou třeba školy, úřady, lékárny, nakreslíte prostě tu druhou mapu s veřejnýma budovama a potom to můžete nahrát do té naší aplikace a hnedka se vám jako dostane zpátky, kolik procent nebo jak moc špatně na tom vaše město je. Celá ta aplikace je na GitHubu, kdybyste měli zájem se na ní podívat nebo něco v ní doplnit, tak klidně můžete. Ještě jsem si vzpomněl na jeden detail, to se vrátím tady k té komunikaci s tou Google tabulkou. Když jsem když jsem si s tím hrál, tak to bylo hrozně pomalé, protože ta tabulka, která měla 42 000 řádků, tak tam jsem byl schopný za minutu updatenout možná jenom 15 řádků nebo tak nějak. Kdybyste někdy něco podobného dělali, tak je dobré tu tabulku rozřezat na více menších, protože já jsem ji rozdělil potom na čtvrtiny, asi po 12 000 a spustil 4 skripty najednou, tak najednou jsem byl schopný za minutu updateovat asi 200 záznamů v té tabulce, takže celý ten dataset 42 000 jsem jakoby překodoval pro 42 000 jakoby adres jsem během 4 hodin jako doplnil přesné souřadnice pro každé z těch míst. Myslím si, že jak jsem se bavil s Manem, že ve Fusion tabulkách to je omezenější, že snad jenom nějak okolo 1000 denně nebo něco, ale to by vám řekl on. Tak to je asi všechno. Děkuju.
Thanks for that presentation. Okay. So, all right. Good. I'm up. Okay. So, hi. Once again, I'm Mano Marks. I'm a developer advocate for, the lead developer advocate for Google Geo. And that means I get to go around the world talking to developers about using our geo technologies, which makes me have the best job in the world. So I'm really happy. So thanks for coming to my talk on Fusion Tables. How many of you have used Fusion Tables before? Oh, awesome. Okay, good. This is actually atypical. A lot of people will a lot of times I do this presentation, only a few people will actually raise their hands. I actually learned a valuable lesson in Japan where I said, the question I asked was how many people had heard of Google Fusion Tables, and everybody raised their hands. And I thought, wow, that's really amazing, since nobody in Japan is using Fusion Tables at the time. Later in it, I asked, how many have actually tried using Fusion Tables? And nobody had raised their hand. So they had heard of it because they'd seen the announcement for it. So it's an interesting cultural difference in the announcement of my talk. So anyway, Google Geo APIs. So Fusion Tables is a part of our Geo APIs family. We like to emphasize that there's lots of stuff going on in our Geo APIs. And today we're going to talk about Fusion Tables and also about the Maps API v3. So the focus is on Fusion Tables. So what is Fusion Tables? Fusion Tables is a data store on Google's cloud. It allows you to store, analyze, and visualize large data sets. Now, I talk a lot about the geographic component of it, and it is the most, I think, well-developed piece of it. But there are other visualizations as well. So this is actually the Guardian newspaper in the United Kingdom. Is a major newspaper. They've been doing tons of work with Fusion Tables, and they're not programmers. So this here, what you see is a map of what's called deprivation, that is poverty and problems that people have. This is just an iframed map created using the Fusion Tables web application. You can click on it and get more details about that particular area. But it also allows you to do other kinds of visualizations. In this case, you see this is another iframed visualization. These are basically the standard Google visualization or the Charts API kind of visualizations. We have some that are built right into the Fusion Tables application, and you can also use it as a data source for your visualization APIs. So this is basically what Fusion Tables looks like, right? You have a table, it is a tabular data table, and you see columns. It's just a spreadsheet, right? Everybody's used to that kind of thing. And then you click on Visualize, and you get a different kinds of visualizations. So in our case, we're going to show maps. So I'm going to actually log in to Google Fusion Tables. So if you've been using Fusion Tables, you may have noticed something has changed in the last week or so. Now, in order to see your tables, where do you go? You go to the Google Doc list, or you can go. There's also directly within Fusion Tables. So here I can click on Documents, and you can see I have certain. I've got lots of different things in here, but I can go right to a Fusion Tables table. So I was playing around a little bit with Mihal's data earlier. I hadn't got it quite working right, but that's basically what it looks like in Fusion Tables. Okay, so back to here. Okay, so since a lot of you have used it before, if you've got a Gmail account, you've got a Fusion Tables account, you can upload data files, and these are our supported data files. So you can upload basic delimited text or KML. Those are the two large ones. You can upload files, CSV or tab delimited files or KML files up to 100 megabytes into Fusion Tables. You can also use Google Spreadsheets, Excel spreadsheets, Open Document spreadsheets. For Excel or Open Document, we allow a maximum of 1 megabyte of uploads. If you've got something larger than that, just export to CSV. And then we allow you to export your files to KML or CSV. And we will geocode your data for you. I'm going to talk about that a little bit more in a minute. And then we also allow you to merge and share data publicly or in the same way with Google Docs in a very similar sharing model. You can share with only a limited number of people. So this is just a chart talking about the different ways to access Google Fusion Tables. You have basically your data, which you can access through the Fusion Tables web app or through the Google Maps API, or actually through a separate Fusion Tables API. And then you have these different visualization options available to you. Okay, so let's talk about the web app a little bit more. This is a application that was, a map that was developed, is Australian ecoregions. So this is, in Australia, areas that have relatively the same kind of terrain. So mountains, deserts, beaches, different areas. And it's got data in there about number of bird species, number of plant species, population per square kilometer. And this is what the table looks like. So you see you've got plants, birds, population per square kilometer, this geometry column, which I'm going to show you in a second, and then a name for it. Now, this geometry column, how many of you know what KML is? Okay, awesome. So KML, Geographic Data Markup Language. All you have to do is put a KML geometry in a cell, and that's what it looks like. So that's a polygon right there. Outer boundary, linear ring, the whole works. You just take that KML snippet, and if you upload a KML file, we'll basically tear it apart, put the geometries in a geometry column, and put any extended data that you have into your data columns. And then to visualize this on a map, you just click on Visualize and Map, and you have a map. And I'm not actually an owner of this, this table with this account, so I could show you how you could actually, you color code the polygons based on, in this case, I think it's number of bird species. So if I click on one of these, I get number of bird species 120. Something that's darker is going to give me a higher number. So you can see, just using the web application, you can create very rich maps without doing any coding at all. Now, this is developer day, so you know that we're going to talk about coding. But just so you know, you can do it without doing any coding at all. We also allow you to map large amounts of data. So a Maps API application running in a browser, especially one that's not a modern browser, has limits on what it can actually display. So anything that can't use Canvas, you're pretty much looking at hundreds of points on the map, right? With Fusion tables, with one table, you can render up to 100,000 rows of data onto a single map layer. So that's quite a huge difference. Okay, so this is just basically another iframed map, but just showing that there's lots of points there. And then we will allow you through the web application to do geocoding directly in the web application. So you can either give us the data, you can give us the data as a KML file, so then we have exact geometries. You can give us a separate latitude and longitude columns, which then we have a exact geometry, but only for point data. Or you can just tell us something like it's Argentina, or it's Australia, or it's this address. You put that into one column, and then we will geocode up to 2,500 rows per day for you. Okay. And how we do it, it's very the height of Web 2.0, where we're not giving you vector data, but when we layer that data onto a map, what we're doing is we're creating a clickable raster. We're creating an image overlay on top of the map that you can click on individual points on that, and it detects what geometry you're clicking on and knows what data to give back to you. So that's how we're able to render large amounts of data in a single layer. So again, 100 megabyte upload, 250 megabyte limit for your account. So a single file you can upload 100 megabyte. You can add to that table, or you can create other tables. Total of 250 megabytes. And then if you can display up to 100,000 rows in a single layer, and we give you this easy user interface to use. Okay. I've been talking a little bit fast because I really want to get to the developer stuff. So let's talk about the developer stuff. Within the Google Maps API, you have direct integration through the Fusion Tables layer. So this is a Maps API application, and you see it's got crime data in a Fusion Tables. This is Chicago. We like to play on the stereotype that Chicago, because in the 1930s we had Al Capone, that there's a lot of crime in Chicago. You can click on individual points and get data, and you can also do things like query that data. So here I can look at homicides that are just within in apartments, or where the victim was age 35 or older. So you can dynamically query layers through the API. So let's take a look at some code. To add a layer is actually just 2 lines of code. You create a Fusion Tables layer, and you assign it a query, which gives it which you say select, and what you tell it is what is the location column that you're using. What's the column that it should look at in the table? In this case, location. It's usually pretty obvious. It's your geometry column, or it's your address, or it's your latitude, longitude, or something like that. And then you assign it a table ID. And that's, if you look at this, the end of the URL, that's the table ID. And it's also available, I believe, in this about the table. So it's right there. Okay. So you do this, and then you assign it. You assign the layer to the map. So in this case, you're you're seeing your standard initialization. You create this map, and then you assign it to the map variable. That's all you need to assign that Fusion Tables layer to the map. But if you want to query, you add an additional element to the query object. And in this case, you're putting a where. So it's just, it's SQL based, right? So you think of a SQL where, where location equals apartment. And then here you also, where age is greater than 31. We have a little bit, some additional functionality though. So this is, I wanted to show a heat map. So this is big earthquakes since 1973 in a Fusion table. And I can just click on Enable Heat Map, and you can see a heat map of where these happen. Now I have to stop and say, because every time I say heat map, somebody asks me later, where did you get the temperature data? And it's a reasonable question. It's really what we're talking about is an intensity map. We use color coding that looks like a heat scale to show intensity of where things are happening. So where it's red, there's lots of earthquakes that have happened since 1973. And where it's green, there's less, and yellow in between, and when there's no colors, there's no big earthquakes between that area. So this is a very useful visualization for you to be able to see exactly where intense things happen. One problem with the HTML5 slides is if you go to an inline demo, you then have to click back on the slide to get back to use your clicker. The other thing that we announced at Google I/O this summer is that you can dynamically style your layers in JavaScript. So how many of you saw the keynote where I demonstrated Fusion tables? A lot of people. Okay, I showed that at the beginning, and you can see here this is that same Australian ecoregion table, but you see that it's actually got a different colors than originally than you originally saw, and that's because in the code we've actually assigned different styles. So basically, what you do when you create the Fusion tables layer is you can actually set the standard query, but you can also set a style as well. And the style can actually be dependent on values within the table. So here we have a style object, and you see here it's got an array of styles. One is this polygon options, and then it's got a fill color and opacity. That's your base style. Every polygon is going to look like that unless it meets some of the other criteria. And you see here again, we have where birds are greater than 300. That's a second style in the array. Polygon options fill color is this. So it changes the style based on values within the table. So you can do this dynamically within code. And actually, the demo that I did in the keynote, I actually dynamically changed it, because you can just, all you have to do is set options to change the query or the style. So you can change that through code based on user input. You can also suppress the info window that would normally be generated and take that information and create a different info window or do something different with it. So this is a case, this is a table of mythical pizza places in the San Francisco Bay Area. And the table has information in it that tells you whether or not they deliver. And so when I click on one, what it does is it says, this one delivers. Let's try and find the one that does not deliver. And in this case, in John's Pizza, it does not actually deliver. So let's take a look at the code for this. So you standard create the layers, and then we're going to add an event listener onto the layer. and it just says on a click, you, instead of displaying the standard info window, you create an info window based on values within the row. So here it's going to give me the row name value and then a break. And then conditionally, if the delivery value is yes, then we say it delivers. So that's pretty easy. But you could also do things like you could take that data and instead of displaying the info window, you could put it into a side panel. So it's available for somebody. Or you could do something that's more interactive with it. Okay, so let's talk about the SQL API. So Fusion Tables has a direct API that you can access. And it's got basically your standard create, read, update, and delete operations. You can create tables, you can delete tables, you can create views, you can read tables, you can add data to tables and take it out. And it's basically, you just do basic get and post. So let's take a look at the table here. This is a table of restaurants in San Francisco. And you'll see it's got an address here that gives you the address of the restaurant. It's got descriptions, some additional information, and then the name of the restaurant. So if I were to post, or to get this request rather, to the API, select the name and address from this table and give me the first 5. This is standard SQL, right? Here it gives me the first 5 restaurants in the table. You can do additional queries like this. So here we've got a nearest neighbor query. So the idea here is instead of some other kind of ordering, we do an order by ST distance. Now this is where we get in a little bit into the geo piece of this. So ST distance is actually an open geospatial consortium standard way of querying for distance in SQL queries. So the Open Geospatial Consortium, they're the ones who manage the KML standard and a variety of other geo standards. They have set out a SQL spec. We support 2 of their SQL query parameters here. So here we've got this order by ST distance. This is basically saying, give me the first 5 nearest to this location. And the result would be this. So it's giving me the entire thing there. You can use this actually within the API as well. So this is an example. This is that data set. There's a lot of restaurants in San Francisco. It's a great place if you win that hackathon and come to Google I/O, because you can eat really well in San Francisco. But here I'm going to show you a example. This is actually intersections. So you see down here we've got this query here. You can use this directly through the API, or you can use it in the Maps API. Select address from this table number, where ST intersects. This is the other version that we support, on address, and then you pass it a circle and a radius. And so what we're doing is saying, give me every point that's within these boundaries, within this circle. And I can change that. I just had a little fail on my slide deck here. Ooh. Okay, let me close down this browser, try and reload that. My nice HTML5 slide deck. Okay. Okay, all right. We fixed it. Okay, and I was on slide 25, I think. There we go. Okay. Whew. That happened the last session. I didn't figure out how to fix it, and then I had this slightly off-screen slides the rest of the presentation. It's very embarrassing. Okay, so here I can actually change this. This is a number of meters, right? So within 100 meters, you find a much smaller area, but I can do within 500 meters or half a kilometer, and I get much larger areas. So those intersections are a very powerful way of, you can use these within your code. So here's the code explained a little bit more clearly. So here we are again, this selects name address from this, this table ID where ST intersects address circle, and then you create a latitude longitude element within the SQL query at this particular location, and then you pass it in a radius. And you can see we can actually do some additional SQL things here. So here, actually this is visible in the side panel here. This stuff here, let's change this back to 1,000. See along here, we're giving you some aggregate information. This may not come out that well because it's a little light. But you see there's 48 restaurants with this, in these dimensions, this category of restaurants, 46 in this other category that are greater than 2,000 square feet, etc. And here you can see if I do these queries directly, these are what I get back. Okay. You can also do create and insert. So these are all post operations here. So you see I have a create table, and then I pass it in column names and types. Again, all this is standard SQL. Insert into a particular table, name and shape, and then these values. So basically inserting in a row. I can select, this is a select query, this is an update query, which gives me a row ID. So this select is actually saying, find me where my house is, and then update it and set the name of my house to Null Island. That's a Myst joke, if anybody knows Myst. Ask me later, you're too young. Anyway, row ID is our internal row ID, which we would only expose through the API, and then we can actually delete that something with that row ID. Okay, so basically, Fusion Tables, powerful, versatile data analysis and visualization platform, allows you to import, manage, visualize, export, and share your data sets. You can work with large geographic data sets. You can do that. You can access that and query that data in a variety of different ways, through the web application, through the Fusion Tables layer, or directly through the Fusion Tables API. And it allows you to style your maps either in the same way, through the Fusion Tables API or the Fusion Tables layer. And actually, Well, here's some additional documentation links here. I'm going to post this to my Google Plus and to my Twitter stream later today, so if you want to find that later. We actually have a trusted tester program for a new API that allows you to style your tables directly through the API, the Fusion Tables API, not through the Maps API. So if you're interested, you can just email this group and request access to the trusted tester program. Thank you. If you want to follow me, there's my follow stuff. Here's some more links to things you might be interested in. And any questions? Yes?
Is there any way how to
visualize?
Yeah.
Is there any way to visualize more than 100,000 rows in a map? First of all, why would you want to? That's a lot of points on a map, right? Any map can take up to 5 Fusion Tables layers. So theoretically, you could have 5 tables, each with 100,000 rows, and display it. In fact, you could actually do one table with 500,000 rows and do a separate query for each one. So theoretically, it's possible. We're also working on ways to allow you to do more than that through, if you have Maps API Premier. And I think you actually can. And if you're interested in that, you can talk to me afterwards. I can connect you with somebody who can do that. Yes, Joe.
Is there a way to do clustering or trickling or controlling the number of map pins on each zoom level?
That's a good question. Is there any way to do clustering or trickling or any other way to control the number of map pins at a particular zoom level? Not as such. You can do it. You can be tricky about it through the API. You can just do queries based on certain parameters. So you could give it a zoom level that it appears at value and only show things like that. But there's no way to do clustering directly through the API. You could, if you have a smaller number of points, you could use the visualization API to grab the table directly, load in 250 points or something like that, and then use something like our marker clusterer. One thing that you can do is file a feature request, because we have a very active, Fusion Tables is, the product is in beta and the API is in labs, but we're putting a lot of engineering work into it. We have a lot of our own products actually depend on the infrastructure that it's on, so we have a very active engineering team, and they look at our feature request page very closely. So I believe that's one of the feature requests, so please go in and star that one, because I want to see it too. Okay, other questions? Yes?
How about the data sources? So, because the APIs are awesome, but we need some data, and maybe there are some tables that are on some open source license or some Creative Commons license.
Right. So that's a good question. The APIs only provide so much direct data. Where can you get additional data? So Fusion Tables, like Google Docs, allows people to create public tables. And in fact, if you want to use a table in a Maps API application, you have to make it public or unlisted. You can, if you have a Maps API Premier, you can actually make it private. I should have mentioned that before. But as a consequence, there's tons of data out there that's already been uploaded to Fusion Tables that's public. So a lot of what you're looking for may already be there. And as we mentioned in the keynote today, Natural Earth Data, which is a great site for public domain geographic data, somebody has already taken all that data and uploaded it to Fusion Tables. So if you want the location of all the lakes in the world, or the boundaries of countries, or what's called administrative level 1, so province, prefecture, states, those kind of boundaries. Those are all in Fusion Tables already. Somebody's already uploaded it. So look for the Natural Earth Data Fusion Tables. There's actually one Fusion Table that's a master list of all the other Fusion Tables in Natural Earth Data, because there's so much data. Also, if you have public domain data or data that you've gotten from from authoritative sources. There's an application called Shape Escape. So if you use GIS data, Geographic Information Systems data, there's a site called Shape Escape which will upload shape files to Fusion tables for you. Basically what it does is it takes the file, tears it apart, converts it to KML, and uploads it into Fusion tables for you. And using OAuth, you just authorize the upload of that data. Yes?
I understand that you can add multiple tables to the map. Can you do something like SQL join of data from different tables?
So the SQL doesn't allow you to do that, but through the Fusion Tables app, you can actually do a join on in Fusion Tables. You can actually merge two tables together. So
So you basically need to create a new table with the data from.
that's correct. So the demo that I did this morning, which was, let me see if I can just pull up a local version of it. This one right here, it was actually created based on a table. I created a table that had the population data. And then I joined it with the natural earth data to get the boundaries of the countries. So that's actually created on a view that's two tables merged together. And it's actually very simple within Fusion tables. You take a table and then you click on merge, and then you merge it with another table with the same ID column. So this case I don't have any data to merge with this table, but you get the idea. Okay, other questions? Yes?
How about using data on mobile device? So maybe how about integration with maps on Android?
Okay, so you asked two different questions. One is using it on mobile devices, and one is on Android. Currently, it's not supported in the Android map view. However, we suggest right now, if you're going to be creating a map for an Android application, you create a web view and load the JavaScript API, and then you load the Fusion tables on top of it. And actually, Fusion tables is really great for mobile applications because the amount of bandwidth it takes to load in this raster, this image overlay, is much lower than the amount that it would take to create each individual marker or polygon using the API. So Fusion tables can be really performant using the JavaScript API, but currently is not supported in map view. Yes?
The obvious question, what about the JavaScript API access for creating and deleting and updating rows in the Fusion tables?
So yeah, so is there a JavaScript API for Fusion tables? Not at the moment. And part of that is because it uses OAuth 2 to actually do the authentication, and that's really hard to do through JavaScript. You have to, you have to do some funky stuff that makes you feel dirty at the end.
Well, is there a chance that we can expect something like that?
We're certainly looking at it and looking at different ways, but currently I wouldn't expect it.
Just recently, some guy put up an app engine site, and you can directly talk through JavaScript, and from the app engine, he's accessing your Fusion tables on your behalf.
Right,
well,
and yes.
It is.
So it's certainly possible to do that, and in his case, he's doing that. But then you're relying on his application to allow you to do that.
That's why
but you can certainly set up your own that just does a pass-through of data to the JavaScript API. The authentication is actually the hard part. Everything else is SQL, and it's just actually pretty simple to pass it through. So it's not that hard. And you get a CSV at the end. So.
And what about that JSON with padding callback, the undocumented feature?
We don't support any undocumented features. So
well, yeah, I'm just asking whether there's a chance that it will be promoted to be.
Sure. I mean, JSON is a great.
JSON data.
Yeah, JSON is the standard for doing web applications, the standard way to pass data around. We're certainly looking at it. Star any feature requests that you can find. Okay. I encourage anybody to star those feature requests, and you can ask Alish. I don't know how to pronounce that little tilde thing on the end. So, so you can ask Alish on which feature requests to actually do. Okay. Yes.
I have a question. Earlier you showed us the sample where you can search points of interest in a certain range around a certain position.
Through the Places API, finding, yes.
This uses a direct, the direct, from one point to one point, the direct route through the air, not the directions.
Correct. Right. It does a search for things within a radius rather than directly through directions.
Yes, but would it be possible to say, if I drive by car from one point to another, and I want to know which point is in the reach of 2 kilometers, would it be possible to get this information?
That's a good question. We don't provide a direct API to our Places or through Fusion tables to find things through driving directions. However, you could do everything within with a very large radius, and then do a distance matrix on it to find which things were closest. So there's ways sort of around that. It takes a lot more of your API quotas to do it, but it's certainly possible, and you'd have to, we could talk about ways in which to get at that. The answer is we don't provide a direct way to do that. That is something that is requested quite a bit, though. Yeah, so star any feature requests.